Hello everybody. Today we are looking at the booklet on graphing inequalities, and it's only one quick lesson. It's a pretty quick, easy job. You have done it before way back in the unit on systems of equations and figuring out which regions to shade and that sort of stuff. So inequalities, we're going to be shading regions. But we have more graphs. When last we looked at it, we didn't have that many graphs. We had straight lines. That's all we had. Now we have parabolas, absolute values, square roots, reciprocals, polynomial graphs, a whole bunch of different types of graphs. And we can now include inequality symbols on them. So let's just have a quick review of our graph types, and then we'll start by dealing with testing points and then by intuition, because they're pretty much the same. Now this booklet here, Graphing Inequalities, extends into the next booklet, which we call Analytic Geometry. So you're going to use the skills you learn here to help you manage the skills in the next booklet too. They kind of work simultaneously together. So let's have a look at some of our basic graphs and see what we can remember from before all this COVID shenanigans happened. Yeah. Okay, so we really have like 5 graph types that we need to be able to be responsible for. We have absolute value, x squared, square root of x, 1 over x, and then the polynomial graphs, right? Now, of the ones that you'll be dealing with, you won't really be working with this one with inequalities because it's not very, it's kind of like a trivial situation. So we're not going to work a lot with that. We'll work with the rest of them. The one that's going to be the hardest is this one here, because we have like a shaded region and then we have undefined regions, and how do we deal with undefined scenarios. So yeah, so let's have a look at, let's remember what these graph shapes look like, how to find vertexes and those sorts of details. Okay, so let's start off with a question like this. Y is greater than or equal to x minus 1 squared minus 3. And we have to, I'll set up the t-chart so you can see how this looks. Alright, so the first step is to graph it as though it was an equation. So up here, right, we see this is an inequality. It's got that, what's that, a greater than symbol, greater than or equal to symbol, right? Yeah, greater than symbol. Y is greater than or equal to x minus 1 squared minus 3. But when I'm starting off, I want to graph it as just an equal sign. So just the line part. And the inequality part lets us know how to shade it. So we start off with the equation, right? And we know that this is a parabola. It's got that x squared in it. So we can find the vertex. You remember how to do that? Okay, so it's the opposite of that number. So plus 1. And then the same as that number over there, right? So that was from the parabola unit and from the general graphing unit, just finding vertexes. And hopefully you're not too rusty about that. So we find the vertex on the graph. So plus 1 minus 3, boom, like that, right? And remember, it's a quadratic parabola, so it has that 1, 3, 5 method. So I go over 1, up 1, right? So 1, 3, 5. 1, 3, 5. So over 1, up 1, and then I have its mirror image. That takes care of that. Over 1, up 3. So over 1, up 3. That goes to there. Over 1, up 3. And its mirror image. Then over 1, up 5. Well, that's going to be way up there. Way up there. 1, 3, 5, right? And my graph looks something like that. Okay, so there's my equation. That line represents the infinite set of points that balance this equation, right? We know what it looks like, we know how to graph it, but that's only part of the job. We've done the equal sign part of it. Now we have to do the unequal sign, or the inequality part, which requires us to shade. So let me set that up. Okay, so the next thing is we need to shade the true region, and we have to figure out what that is. This, parabola that we've drawn splits our graph paper, which we call the Cartesian plane if we want to sound all fancy, but splits our graph paper into two separate sections. One is true and one is false, and we have to determine which side is true. And the most precise way to do it is to pick a point that's clearly in one of the two regions and test to see whether it gives us a true statement or not. So inside all this area here, or outside, right? All this area to the outside, right? So either inside or outside. Sorry, I'm having to do this in a mirror, so it's kind of tough to see. But we have either of those two regions. Now the easiest point to pick, and the one that I always like to choose, is 0, 0, right? That's the easiest point to pick. We know it's right here. It's in the inside region, so it's very easy for us to test that point. I might ask you guys, when's the only time you can't test that point? Right, when it's actually on the line, because otherwise it doesn't give you any indicator of which side is true and what side is false. So we're going to take 0, 0 right here, and we're going to test it. Okay, what does that mean? Well, 0, 0 is a point, right? It's an x and a y value. And if we plug it in up here, it will either give us a true statement or a false statement. So let's see what happens. So 0 for the y, it goes in the y spot. 0 is greater than or equal to, okay, 0 for the x, so that goes there. 0 minus 1 squared minus 3. And we want to see if that statement is a true statement or a false statement. So let's have a look, right? 0 is greater than or equal to, what's negative 1 squared is 1. 1 minus 3, so 0 is greater than or equal to negative 2. Is 0 greater than or equal to negative 2? Yep, it sure is. So what it means is that because this point 0, 0, when we plug it in, gives us a true statement, it means that this point and all the other points in that region are also true. And so all you have to do is shade the appropriate region. Shade it in. What we're symbolizing by shading it in is by saying, well, every point, every xy point that's in there, right, every little xy point that's in that region will produce a true statement when you sub it back into the original inequality. And so you just test one to see whether it's true or not, and it applies to all of them. Now, what would you think would happen if this changed from greater than to less than? Well, I'd still plug in the zeros all the way through, but down here at the bottom, when I'm doing my testing, I would be using that symbol there. I'll be using less thans, and then what I would get would be a false statement. And so in that case, this middle section would be empty, and you would shade the other region because you know that this one would be false, so the other region would have to be true. And so it's just a matter of plugging it in and checking it out. And if you do it this way, you'll never go wrong. It'll always treat you fine. There's some situations where what you think it might be might backfire on you because of how inequalities work, especially with dividing by negative numbers and stuff. But for the most part, you'll always be able to get it right if you test a point. But you can, if you wish, use your intuition. Okay? You have to remember what these symbols mean, right? So originally we had this symbol was greater than, right? Greater than or equal to. So if you think about greater than or equal to, and you think about words either above or below, greater than typically means above. Well, check it out, right? Here's our line, right, all of this, and we shaded above, because that is a greater than symbol. And if you remember, if you just scroll back a little bit, when we changed it around, it was less than, and the less than was all this stuff down here, right? So the stuff that's below the line. And you can use that quite consistently in this work that you do. In fact, some of you may choose to do it that way, and I don't think it's going to give you any problems, not like it did way back in the first unit when we were dealing with straight lines. So that's that one. Let's have a look at a couple more examples and see how things play out, okay? Okay, here's another example, right? Y is less than or equal to negative absolute value x plus 2, and the absolute value, and then another plus 2. So we have to start off by remembering the shape. It's a V graph. Which direction is it going? Down. Why is it going down? You get a negative sign right there. Negative means it goes in the downward direction. And the vertex, right? So remember the vertex. The opposite of that number first, and the same as that number second. So minus 2 plus 2. Minus 2 plus 2. Okay, I can find that out, right? Minus 2, 1, 2, and then up 2, right around there. So minus 2 plus 2. There's my vertex. Okay? And remember the slopes are 1 and negative 1. So that means I go over 1, down 1, over 1, down 1. It goes through the origin, actually. I did that on purpose. Goes like that, and this one goes over 1, down 1, over 1, down 1. So there's my equality. That's what it will look like as an equation. And now I've got to figure out which side is true and which side is false. So judging from the symbol, right, that's a less than or equal to symbol, right? Because if you can make the letter L out of it, L when you're looking at it, when you can make the letter L out of it, that's less than. So there's that shape, and then I just tilt it to make the L, so that's less than. So less than typically means below. And my guess would be that I shade the region below that line. Well, let's test a point to make sure. Now, typically we try to test 0, 0. But 0, 0 is on the line. And as I was mentioning in the last example, if I test 0, 0, it doesn't give me any information about which side is true and which side is not true. It's right on the border. And so I don't get any value out of testing that point. So we just have to find another point. And why don't we try testing the point, say, right here, and see if that's true or false. We'll test the point 0, 3. Right? Test. You can pick whatever point you like, but I like to try to keep at least one of my variables equal to a 0, because then it just makes the calculations simpler. 0, 3, right? So 0 is your x value of your point, and 3 is your y value of your point. I plug those in. So let's see what we get. I get 0 is greater than or equal to negative absolute value of 0 plus 2 plus 2. Okay, so that's 0 is greater than or equal to negative absolute value of 2 plus 2. Sorry, 3, that's a 3 up here. What am I doing here? Ah, totally bonfooled it. Nah. Yes. It should be a 3 in the y value spot, not a 0. Right, so there we go. Ding. Oh! Okay, so absolute value of 2 is 2, so I get 3 is less than or equal to negative 2 plus 2, right? There's that, and there's that. So 3 is less than or equal to 0. Is that true? Is 3 less than or equal to 0? No, it is not. 0 is greater than. Sorry, 0 is less than. So this is backwards. 3, the sign should be backwards. So this is a false statement, which means all this region up here is false, right? False here, false here, false here, false there. The only place that's true would be down here. This region here would be true. And if you really wanted to test it, you could take a point in that true region, say down here, you could take the point, say, 0, 1, 2, 3, 4, 5, 6, 0, negative 6. You could plug it in. Well, everything would be the same, except these would be negative 6's. Right? Negative 6's, and this would be a negative 6 down here. And then you would have a true statement, which would indicate that this is indeed the true region. True. So, and it falls in line with our intuition, right? Less than, below, easy peasy. Unless you have a teacher that can't do math. How did I get this job? Okay, so that's that one. Let's have a look at 2 more examples. Okay, so here's a polynomial graph, right? And so I'll draw out the original and we'll go through the quick shading. This won't take long because you're starting to get the hang of it already. Okay, so there's our shape, right? X-intercepts and Y-intercepts, you know, going through the usual process. And, you know, just by using our intuition, less than should be below. So if I was to test a point like 0, 0 in this region, that 0, 0 should come out as false. And if you go through the process, you'd see that that's true. You just test the points if you like. So it's in the bottom section, it's the part that's below, and we just shade that, right? Pretty easy. And you can go through these questions quite quickly just using your intuition like that, right? Less than is below, greater than is above. Okay, so that's what it looks like. You can just shade those regions. That's good enough. That's full marks for what you need to be able to do. Now the last one is square roots, and those are a little bit tricky. So we'll spend a little bit of time talking about what's going on because you really have 3 sections to sort out. Here we go. Okay, so this is you know, this is what you'd be asked to do on a typical type question. You'll see that in your work. So how do I manage that? Okay, so it's harder than it looks at first. We have to start off with the graph of the equation. So we start off, you know, what is the vertex? Right, it's the opposite of that number, so negative 3, the same as that number, number 2. I mean, that's all theory that we had gone through way back in, you know, October, November, December, January, February. We talked about that consistently, so I hope that's not a shock or surprise to anybody. So we find our little vertex, negative 3, positive 2, right there. What does the negative on the outside mean? It's the same as what it is for absolute values and all that. It means it's going in the down direction. So it's a half parabola going in the down direction. So something like this. Over 1, down 1. Over 3, 1, 2, 3, down there. 1, down 5, so way over there. The graph looks something like that. That's not the best, but that's what the graph winds up looking like as an equation. And now we have to deal with the greater than symbol. And you think, okay, greater than, that's above, right? So that should be fine. So that's everything above, but okay, we got above over here, but we don't have anything over here. Is that above? Do I draw a line? What do I need to do? Okay, so this is where it gets a little bit complicated, and this is really the next level up in dealing with these types of questions. And it's only this particular question that you have to worry about. So, what we have to also do is we have to think about the undefined space. We are not allowed to have x values that go less than negative 3. And the reason for that is quite, you know, there's many reasons for it, but if I have like a negative 4 in there, I get the square root of a negative number, right? If I stick in negative 4, I wind up getting the square root of negative 1. We're not allowed to have the square root of negative 1. So that's why we have that situation. And this whole region over here is undefined. So undefined. There's no shading, there's no anything over here. It's kind of like saying what's north of the North Pole. Right? can think, well, maybe the North Star, but we're not really dealing with that. So it's the same idea. There's nothing there for us to measure or deal with. We wind up getting square roots of negative numbers. So there's no shading in that region, in the undefined region. And when you're dealing with square roots, you have to watch for it. And the simple answer is, where's the vertex? Anything to the other side of the vertex is going to be in the undefined region. So that's a very easy place to look for. You don't have to really break your brain open too hard. And then, so now really we have the undefined region, right? That's everything on the other side of the vertex. And then on the other, like on the normal side of the vertex where we have proper answers, where we see a graph, then you worry about whether this is above or below. And of course that's greater than, so greater than equals above. Bada bing, bada boom. It's going to be shaded in the above region. And you can test a point if you like to see if that's true. So you test it, right? It's everything that's above that line going off to infinity, right? You can test a point to see if it's true or not, but it works all the time like that. So you have to, when you're dealing with square roots, you have to worry about the undefined space, and that provides like a kind of like an artificial barrier that you have to watch out for. Okay, so really that takes us to the end of our booklet. There's not much more to talk about. These are the types of questions I'm getting you to think about, and we're going to jump and take this to the next level when we start looking at something called analytic geometry. And really, the next booklet is the key to the entire course, because we've been building your algebra skills on the one hand and your graphing skills on the other hand. And now I want to show you some of the techniques that allows us to expand both of these concepts together and, you know, expand your power of dealing with problem solving. And it's a incredibly powerful tool that any person who's pursuing any sorts of science, engineering, even economics or anything like that that requires a significant amount of math, you're going to want to know how to manage analytic geometry, because it just makes your problem solving so much quicker and faster. The better you are at it, in this next booklet, then, you know, just the more insightful your analysis of all the kinds of data that are out there will be. Right? You just have you're going to go up several levels over the next couple booklets for sure. All right, so that's just me. I hope you guys are doing well, keeping safe, and look forward to seeing you guys as soon as I can in person. All right, and remember, if you run into problems or whatever, you can come and see me on the weekly chats that I have in Edmodo. You don't have to sign up on time. You can sign up later on into the session. You can come in at 2 o'clock or 2:30. Right, I go from 1:30 to 3 on Thursdays. So come in and join me then if you have any other questions. All right, guys, take care.